The best practices for building critical systems revolve around characterizing the various worst-case failure scenarios. In particular, you need to mitigate the absolute worst-case scenarios that could possibly happen, whether or not you intuitively deem them to be likely. Each scenario should be assigned a SIL according to a relevant safety standard. You should then use engineering rigor appropriate for that SIL for software and use appropriate hardware redundancy as well. Finally, you should consider fleet exposure in terms of number of failures that will happen across the entire fleet at a particular severity, rather than whether any one unit will fail or not. This will ensure that you have followed a methodical approach to minimizing risk rather than going by the seat of your pants. There are several big pitfalls in building critical systems. The first is that software redundancy is a very difficult topic because independent failures require diverse software, and measuring or even attempting to get diversity in software is challenging at best. In practice, diverse software is not something you can get perfect. The general solution to this is simply to look at the highest SIL allocated to a component and write all the software for that component according to the requirements of that SIL, so it is effectively perfect for the level of SIL required. The next big pitfall is that designers' intuition about what faults might be realistic is almost always hopelessly optimistic, and in general not to be trusted. That's because even the smartest, most experienced engineer is going to be less than 1 million hours old, so they will not have personal insight and experience with failures that happen every 10 million or 100 million hours. It's a real struggle to imagine such things, let alone use intuition to decide which things are really going to happen or not. Catastrophic events happen to individual systems so infrequently that it's likely that no one in the team has seen or heard of that type of event, much less experienced it in person. However, these are exactly the types of events that do cause catastrophic failures in the real world. One way to help mitigate this lack of personal experience with catastrophes is to consider what will happen in a malicious case. So you assume a malicious adversary is trying to make your system fail. Ask what the worst they could do is, and say, okay, that could also happen by chance at 1 per billion hours, so we have to mitigate it. This approach avoids the natural tendency to dismiss hazards that designers don't have personal experience with. Finally, a strong safety culture is an important asset to creating critical systems. Going through the motions is not enough. Even if you're using a SIL-based process, safety first has to be more than a slogan and must permeate the culture of any organization designing safety-critical systems. History shows us that most, if not all, catastrophic system failures happen because of a broken safety culture and not because of simple operator error or technical mistakes made along the way.